Good day, my name is Joanne Creyer, student number 629-33590. This is my transportation, engineering, pavement and geometric design presentation for the upgrade of the Rift Valley Road, which is located to the east of Malibongwe Drive and south of the R114. The project details. Currently, Rift Valley Road is a one-lane, two-way gravel road of approximately 2.6 kilometers. It currently provides access to 19 urban, of which all are farmland. The proposed upgrade will be to increase the lanes to 2 lanes per direction, which is then 4 lanes. It will be a cemented Class B road of approximately 3.3 kilometers long. It will still continue to provide access to the 19 urban, but will also join the Lion Pride Lifestyle Estate. This will allow an additional route to control the amount of traffic from the Lion Pride Estate. For the geometric design, I used a design speed of 60 km per hour. Using TR17 and 60 km per hour as my base, the minimum K value was found to be 60. A minimum curve length of 100 meters must be used, and the maximum allowable gradient is 7% for rolling type conditions, as the conditions of this site is considered quite steep. From the design, I could then obtain the PVI chainage and elevation. I used the minimum length of 100 meters for the design and obtained a gradient of minus 5.93% coming in and positive 4.76% going out. This is below the maximum previously stated. This is due to the fact that the curve type is a sag curve. We can then use these values to calculate the chainage and elevation of beginning of vertical curve, end of vertical curve, and the lowest point of the curve due to the fact that it is a sag curve. The calculated stopping site distance was first used under the conditions where S is smaller than the curve length. This gave a value which did not comply, therefore we had to use the second formula, which was S is greater than the curve length. I also checked the minimum curve length, which was then found to be inadequate. In order to rectify this inadequacy, we could change the gradient coming in or going out. If we were to change the gradient coming in, we would have a problem with the amount of cut that would need to take place. Although this is in a design level, not a problem, the cost implications for practical purposes would be a problem, as the feasibility would need to be increased. If we were to change the design speed, the minimum length would also then change, or we could restrict overtaking at this particular point. The pavement design was given as being a cemented Class B road with a structure S2 wearing course, a 150 mm C3 base layer, a 300 mm C4 subbase, and then using a CBR of 18.5%, the subgrade layer, I got a cover of 175 mm using the 40 kN medium wheel load graph. This gives a total cover of 625 mm on top of the in-situ subgrade. The proposed drainage for this project is a paved V-drain along the shoulders of the Rift Valley Road. The V-drain will be placed on both sides of the road, as the super elevation is 2% going down towards this curve. The water will then flow southbound towards the bend of the road into the Lion Pride Lifestyle Estate. Where a low point is encountered at the top of the road, a chute will be built to break the flow of water and slowly discharge into the road reserve, which was set out as 40 meters. It will act as an attenuation dam, allowing the water to flow into the road reserve. If the road is ever to be extended and an increase in lanes is considered, then an underground water system, stormwater system, must be built and designed correctly. Okay, To physically create the design, I used a computer software called Civil 3D. This is an extension of the AutoCAD software. The cadastral and contour information of this proposed road was provided to me by my mentor Louis Fourie, as he's the project manager for the Lion Pride Lifestyle Estate. Therefore, the information was provided. I used the provided contours to create a surface in the program, naming it the Natural Ground Level, or NGL. This surface was then used to create a contour base map or tin surface, which can then create a visual representation of the natural ground level. After this, I created an alignment from the center of the road, starting at the points near the farmlands and ending at the point in the Lion Pride Estate. This gives a 3.3 kilometer road. From the alignment, I could create a profile. This profile will then be called the vertical curve. The design criteria, such as the curve length, is inputted into the program so that it automatically takes into account all standards set out. I can then move the design level on the graph and adjust the gradients of each curve so that it stays under the maximum gradient stated from the TRH17, which in this case was 7%. I created an assembly. This assembly is the details of the pavement structure. It also shows the drainage, which is a conceptual idea for this project. The slope of the road is also included, which in this case is stated as 2% going left and 2% going right. The next step would be to create the corridor. The corridor is the physical road being designed. This will use the vertical curve from the profile and the assembly created to design the road. The minimum horizontal radius must also be stated, and all horizontal criteria must be included for the road to be deemed accurate. From here, the levels can be visually interpreted as being steep or flat. If the contours are closely packed together, the road is quite steep at that particular point. If they are far apart, it can be quite flat, which can cause drainage problems. These changes can then be changed on the vertical curve. Where necessary, the heights of the curve can be changed. Then you just rebuild the corridor to give a better visual representation of the road. Okay, next sample lines are created. This will then help obtain the cross-sectional and longitudinal information. This will give a visual representation of where the design level is in cut or fill compared to the natural ground level. Also use the corridors to create or calculate and obtain the volume report. This aids in producing the mass hall diagram as requested in the brief. Each drawing obtained in the program must also have the necessary information, such as the name of myself or the designer, the student number, the title of the drawing, as well as the number on the drawing. The last requirement for the project brief was to create a calculator using Excel to automatically calculate the vertical curve. The first thing to identify is the type of curve. Is it a sag curve or a crest curve? This will then determine which calculator to use. Once this is known, the following information must be inserted into the calculator. The PVI change and elevation, G1, which is the incoming gradient. For a sag curve, it is negative, and for a crest curve, it would be positive. Then the G2, which is the outgoing gradient. For a sag curve, it would be positive, and a crest curve, it would be negative. You will also need the length of the curve in meters. The output data that you would get would be the lowest or highest point, the change in elevation of this point. Again, for a sag curve, it would be the lowest point, and then for a crest curve, it would be the highest point. You will also get the change in elevation of the beginning of vertical curve and the end of vertical curve. The entire calculator can be deemed user-friendly, as there is an illustration to help determine the type of curve as well as the direction of it, so positive or negative. Then there is a highlighted area of the inputs required. This will allow ease of access for any user to insert the data that is required to receive the data that they are looking for. This concludes the presentation for the upgrade of the Rietvellery Road from a gravel 2-lane road to a 4-lane cemented road. The software involved in this project was the AutoCAD Civil 3D software. Google Earth was used to get the locality plan and coordinates, as well as the initial length of the road. All information provided was given to me by my mentor Louis Fourier, who is a registered engineer with the Engineering Council of South Africa. He has also reviewed all the drawings and the design in Civil 3D, and from his comments and suggestions, I have ensured that the design is correct. Theoretically, I do believe that only a minor change would need to be made to ensure the design is 100% accurate, such as ensuring that the length of curve is greater than the minimum length which was calculated previously. I do thank everyone for listening to my presentation. Thank you.